Happy Wednesday, everybody. So let's take a look at these two warm-up problems. Like always, I want you guys to pause the video, try them out, and I think I'll just put up the answers. So go ahead and pause now, come back, and you can check your answers. All right, so here's the answers to the two warm-up problems. Notice in the first one, we were just proving the triangles were congruent. So I ended with an angle side angle because that's what proves triangles are congruent. Remember, that's one of your 5 ways to prove triangles are congruent. But then if you jump over to number 2, notice I ended with CP/CTC because I was proving that corresponding parts of the triangles were congruent. So first, I showed that the two triangles were congruent by hypotenuse leg. Then, because the two triangles were congruent, then I could say those corresponding parts are congruent. All right, those are pretty straightforward proofs. Mostly everything was given to you there. If you need to pause so you can get it down or look at it again to review, that's fine. Pause now. If not, let's go ahead and look at what we need to look at today. Oh, and just so you guys are aware, before we move on, the reason we're doing this triangle congruence is because I want to try to keep that stuff kind of fresh in your mind so you don't forget it by the time the UC comes around. So it's something that I want to keep fresh in your mind, and then also it kind of prepares you if you want to retake that congruence test. This is kind of a way to refresh that kind of stuff. All right, but let's talk about what we need to talk about today. So goals for today. We're going to be looking at 2 things. We're going to be looking at this concept where if I'm given a single trig function, like the sine of theta is 4/8, what we're going to be able to do at the end of today is take that one piece of information and we're going to be able to identify the sine, cosine, and tangent of all the angles in the triangle. So it's pretty neat stuff. Given one piece, we can find everything else. And then after that, we're going to use something called trigonometric inverses to find acute angle measures in the triangle. So up to now, we've only been finding side lengths. And so now today what we're going to learn is how can we actually find those angle measures in the triangles. All right, so let's jump right in. So here's our first example problem, and you guys should have a sheet there that has this example problem on, so you can just write it down if you want to copy it down once you get the note, or cut it out, sorry. Once you get the notes done, that's fine too. That way you can put that into your notebook. But let's take a look at what this says. So this is kind of like what we ended class with yesterday in the recap session. But let's read through. It says, if triangle ABC, or in triangle ABC, the cosine of A is 4/5 and the tangent of B is 4/3. All right, so let's look at that and see what can we take from this information. So it says in triangle ABC, the cosine of A is 4/5. So if you guys remember your SOHCAHTOA, sides opposite over hypotenuse, cosine ka, adjacent over hypotenuse, and tangent TOA, opposite over adjacent. You guys remember those, and this says the cosine of A is 4/5. So that means cosine being adjacent over hypotenuse. So what that tells us is that 4 has to be adjacent to angle A, and 5 has to be the hypotenuse. So if we come over to our triangle here, ABC, what we can say is that looking at angle A, 4 has to be adjacent to A. So that means it has to be next to it. So 4 would have to be there. And 5 has to be the hypotenuse, the longest side, the side opposite of that right angle. So that needs to be 5. All right, so we got 2 sides of our triangle already. Let's keep reading, see if we can get that 3rd side. Otherwise, we have to find another way to figure it out. Okay, so now it says, and the tangent of B is 4/3. All right, so notice we had A in this one, but now we're looking at angle B. So this is the tangent of B. So if we come up here, now we're looking at angle B, so this angle here, and tangent is opposite over adjacent. So that means 4 needs to be opposite of B, and then this 3 would have to be adjacent because tangent is opposite over adjacent. So we come over to our picture. Angle B is going to be 4 needs to be opposite. So if we go opposite of angle B, hey, look, there's the 4. We're good there. And then adjacent next to B, that's going to be this side here, BC, that needs to be 3. So now, if you look, based off of just those 2 trig functions, we've gotten all three sides of the triangle. Now, this is a special triangle. This is what's called this 3, 4, 5. This is called a Pythagorean triple, which basically means that if you did the Pythagorean theorem that a squared plus b squared equals c squared for this, it would work out. And this triangle shows up a lot. It may not show up as 3, 4, 5. Sometimes it shows up as like 6, 8, 10, or 9, 12, 15, multiples of 3, 4, and 5. But this triangle is going to show up a lot. So if you remember this 3, 4, 5, that's going to help you out a good bit. But just a little side note, you don't have to memorize it. So we got this 3, 4, 5. So now let's look at what is the question actually asking us to find. It wants us to find the cosine of b, the sine of b, and the tangent of a. So let's go ahead and write this stuff down. Cosine of b. So angle b we did in blue, so I'm going to keep that consistent. Cosine of b. Fix that parenthesis, I don't like it. We look, b is here, and we know cosine is adjacent over hypotenuse. So we just need to take a look, well, what is adjacent to b? Well, that's going to be the 3. 3 is adjacent to b. And then what is the hypotenuse? Well, that's going to be 5. So the cosine of b is just 3/5. So that's that one. That's all we need to do. It's not asking us to find anything else. It just wants us to find what is that ratio that the cosine of b is. So the next one, sine of b. So we're sticking with angle b, so I'm going to stick with blue here. So angle b, again, we want to find sine though, so come up to your SOHCAHTOA. SOHCAHTOA, sine is opposite over hypotenuse. So I'm going to come over here, look at angle b. Opposite of angle b is 4, hypotenuse is 5. So the sine of b is 4/5. Okay, and now if you guys remember before we move on, remember that property that said the cosine of one angle is going to be equal to the sine of the other angle. So if you look at that, isn't that what happens? Sine of b and the cosine of a are both 4/5. So just a neat little thing. You can kind of use that even to, instead of just looking at the triangle, you just know that those two are going to be equal. All right, so now finally, last one, tangent of a. Now for a, I used red, so I'm going to switch to a red color here. The tangent of a. Now if you remember, tangent, so come up here to your SOHCAHTOA, is opposite over adjacent. So I need to look at angle A because I'm taking the tangent of angle A. I need the opposite to angle A, so that's going to be a 3, and the adjacent is going to be a 4. So tangent of A is 3/4. If you guys remember that property from yesterday, where I said that the tangent of A is going to be the reciprocal of the tangent of B, this was 4/3, isn't 3/4 the reciprocal of 4/3? Okay, so that's how we know that that works out. Just a way to check too. But if you don't remember that, as long as you know your SOHCAHTOA, you can just look at the triangle and go from there. All right, first one done. Not too bad, right? Let's take a look at the second one. I think this one's going to take this a step further here. So if you guys need to rewind the video, pause, go back to that page. If not, let's take a look at example 2. So in this one, let's read through. It says, in triangle DEF, the tangent of E is the square root of 3/1. Okay, let's break that down before we even move on. So let's write our SOHCAHTOA up here. Make sure we remember it. So, S-O-H, Ka, C-A-H, Toa, T-O-A. So, tangent is opposite over adjacent. So, square root of 3 needs to be opposite of that angle E. And 1 needs to be adjacent to angle E. So, let's come over here, find angle E. And we said square root of 3 needs to be opposite of E. And 1 needs to be adjacent to E. So now from here, this is all the information we have. They don't give us anything else, and it wants us to find all of these answers. So what we need to do before we can do anything else is we need to find this missing piece here. Now to do that, to find that missing piece, this is a right triangle. So there's this formula, or this theorem, that I'm pretty sure most of you know about right triangles. It says this, and we talked about it on the last page, a squared plus b squared equals c squared. So if we want to find this third side so that we can find all these things, we need to do this theorem. So to do that theorem, what we're going to do is assign these some values. So this we'll say is a, we'll say this is b, and then keep in mind the hypotenuse is always, always, always c. So that longest side is always c. If you want to make that note, in case you don't remember, c is always the hypotenuse. A and b are kind of interchangeable. It doesn't matter which leg is which. But let's go ahead and substitute in these values. So we got the square root of 3 squared plus 1 squared is equal to, in this case, x squared. So on this side, let's simplify. Square root of 3 squared. Now, I don't know if you guys know this, but a square root and a square are inverses. So when you have those, what happens is those actually cancel each other out. And so if those cancel out, the square root goes away, the square goes away, all we're left with is the 3 plus 1 squared, 1 times 1, well that is 1. So 3 plus 1 is equal to x squared. Now simplify this from here. 3 plus 1 is 4. Bring down your x squared. So now, finally we want to get this equation where x is by itself, so I need to get rid of that square. So to get rid of a square, the inverse of that, like I said up here, is the square root. So if I take the square root of x, that's going to cancel out that square. So I'm going to have the x left here. But if I took the square root of this side of the equation, I need to come to the left side of the equal sign, take the square root of that whole side. Now the square root of 4, hopefully you guys know, is 2. So that means that our x value, this side DE of the triangle, needs to be 2. So that means that that side is 2. So now that we've gotten all three sides of the triangle, we can make some pretty quick work of getting these formulas, or getting these ratios. So cosine of E. Cosine, adjacent over hypotenuse. So I'm going to go up to angle E. Adjacent to angle E is 1. Hypotenuse is 2, that value we found. All right, sine of E. Looking at angle E, that's opposite over hypotenuse. So the opposite of E is square root of 3. Hypotenuse is 2. So that's that one. Next one, we're going to switch colors since we're dealing with D now. Tangent of D. Tangent, if you guys remember, is opposite over adjacent. So from D, the opposite side is 1. The adjacent side is square root of 3. So we're going to write this as 1 square root of 3. Now technically this is not what we call simplest radical form. But we're going to leave it like this and come back to it. I want to finish getting the rest of these answers and then we'll change that to the way that we need to. All right, so next one, sine of D. So again, we're back at angle D here. Sine is opposite over hypotenuse. So the opposite of D is 1. The hypotenuse is 2. Notice again, the cosine of E is equal to the sine of D. That always happens. The cosine of one angle is equal to the sine of the other. All right, so following that same suit, the sine of one angle is equal to the cosine of the other. So that means that this cosine of D should be square root of 3 over 2. But if we want to check, we can go back up to the triangle here. Cosine, adjacent over hypotenuse. So if we're looking at angle D, square root of 3 is adjacent. Hypotenuse is 2, so cosine of D, square root of 3 over 2. All right, so this one here. Now we got the rest of these answers. Let's look back at this. As mathematicians, we don't like square roots in the bottom. It's kind of like someone before they have a makeover. We don't like it. So what we need to do is we need to give this expression, this fraction, a makeover. Now to do that, what we're going to do is we're going to multiply whatever's on the bottom here by itself. So we're going to multiply by the square root of 3 on the bottom. Now if you keep in mind, when you multiply a fraction and you don't want to change its value, what you have to do is you have to multiply both the top and the bottom of the fraction, the numerator and denominator, by the same thing. So this is just a mathematical thing. It's not really a huge deal if you just said, let's not even put that in. But this is technically the full correct way. So what we need to do now is we're going to multiply both of these by square root of 3. So top part, 1 times the square root of 3. Remember, when you multiply fractions, you multiply across. So 1 times the square root of 3, that's just the square root of 3. This part, and the whole reason why we multiply it by itself, if you take the square root of 3 times the square root of 3, what that gives you, 3 times 3 is 9, so we get the square root of 9. And the square root of 9 is 3. So really what we get is just 3. So notice the square root is now gone, because square root of 3 times square root of 3 is just 3, and we're left with this as a final answer. And this is what we like, but this actually will give you the same value as this here. If you put both those in the calculator, you would get the same answer. All right, so example 2 down. If you need to pause, check this out, that's fine. If not, let's go ahead and look at one more example, and then I'll give you guys some time to do some on your own. So last example, notice something here. They do not give us a triangle. So what we need to do is make our own triangle. Before we do that, let's look at this problem. It says, in a given triangle, the sine of, remember that's called theta, is the square root of 3 over 3. All right, so let's go ahead. Let's draw a right triangle here. So we got a right triangle. And they say the sine of theta. So that means one of our angles is theta. Now it doesn't matter which one we use. I think I'm going to use this top one to be theta, but you can use the bottom one if you want. It won't matter. So this top angle is theta. If you guys remember, let's write out our SOHCAHTOA just so we can reference it. SOHCAHTOA. The sine function is opposite over hypotenuse. So that means square root of 3 must be opposite. 3 must be the hypotenuse. So if I come over to the little triangle I made, again, it doesn't matter which angle you pick because they don't specify which one it is. It just has to be one of the acute angles. So theta here, this is going to be the square root of 3 because that's opposite of theta. And then this is going to be 3 because that's our hypotenuse. So that's what we got so far. Now, the problem is we don't know that side. So to find that side, we're going to do the same thing we did before. We're going to use that Pythagorean theorem to find the third side of a triangle. So if you have two sides, to find the third side, you always use Pythagorean theorem. Might be a good note. To find third side, use Pythagorean theorem. Might be a good idea to write that down, guys. So from here, all we need to do is use the Pythagorean theorem to find that third side. Now to solve this out, what we need to do is figure out what's A, what's B, what's C, because, you know, Pythagorean theorem, A squared plus B squared equals C squared. So remember, hypotenuse is always C, and then A and B are perfectly interchangeable, so it doesn't matter which one's which. So we'll call that A, call that B. So let's substitute in our values here. A we know to be the square root of 3. So square root of 3 squared plus b squared we don't know is equal to 3 squared. So let's simplify this out. Remember, a square root and a square cancel each other out, so we're left with 3 there. Plus b squared is equal to 3 squared, so which is 9. So now we got to continue solving for b here. So solving for b, we got to get b by itself, so we got to get rid of that 3. So to get rid of that 3, we're going to subtract it from both sides. Cancels out there. We're left with b squared is equal to 9 minus 3, or 6. And then finally, to get rid of that square, remember you take the square root of both sides. So that cancels. I'm left with the b here is equal to the square root of 6. So we're going to come back up here. Oops. Come back up here. B is equal to the square root of 6. All right, and we can leave that like that. We don't have to get the decimal. It's actually easier to write the fractions if we leave it as that radical, that square root. All right, so let's take a look. Next part. Change colors here to make it a little easier to see. So cosine of theta. So we're finding angle theta. That's this angle here. That's theta. Cosine we said is adjacent over hypotenuse. So we got to go adjacent side over the hypotenuse. So we're going to say square root of 6 over 3. So that's all there is to that one. Okay. Next one, tangent of theta. So tangent is opposite over adjacent. So it's going to be square root of 3 over the square root of 6. So again, we got a radical in the bottom here, so we're going to have to come back and rationalize that. But let's leave it like that for now. Let's jump over here and look at these three. Now, 90 minus theta. That looks confusing. It looks like something you have to solve. But this isn't anything you have to solve. All this is referencing the other angle in the triangle. This is your 90 minus theta. Think about it. In a right triangle, the two acute angles have to add up to 90. So if this one's theta, to get whatever this one is, we'd have to do 90 minus that theta. And since we don't know what theta is, we gotta just kind of leave it as theta. Okay, so now we kind of got that concept down. 90 minus theta is just that other angle. That's all it means. It means we're looking from this point. So to find the sine of that, we're just gonna do opposite over, let me erase all this, it's getting messy in here. We're going to do opposite over hypotenuse. So square root of 3 over 3. Next one, cosine of 90 minus theta. So cosine is adjacent over hypotenuse. So it's going to be, oops, I messed up sign. This should be square root of 6. Sorry about that, guys. This is going to be square root of 3 over 3. And then finally, tangent of 90 minus theta. So what that's going to be is tangent, we know, is opposite over adjacent. So it's going to be the square root of 6 over the square root of 3. Okay, so here's what we got. So now all we need to do is we need to look at these last two here and rationalize those. So that means get rid of that square root on the bottom. So if you remember, the process for that is to multiply by itself. Multiply by itself. So if we multiply by that denominator square root of 6, square root of 6 times square root of 6, that's 6. Square root of 3 times square root of 6, that's just going to become the square root of 18. Okay? So that's all we got to do for that one. You just multiply those numbers inside the radical. Same thing for the other one. We're going to multiply square root of 3 times the square root of 3. On this side, square root of 3 times square root of 3, that's going to, square roots kind of cancel. We're left with a 3 there. And on this side, square root of 3 times the square root of 6 gives you square root of 18 again. All right, and that's really all there is to it. Okay, guys, so if you need to pause, check this out. I know we just did a ton of math. What I want you guys to do, though, is once you get this down, once you got it paused, get it all down, take a look at these two problems, 1 and 5. So take a look at those, see if you can figure them out. Pause, maybe take about 5 to 8 minutes to work on those two, and then come back to check your answers. So go ahead and pause now. All right, guys, so here's what we got for number 1 and number 5. If you want to check your work there, take a look. I got some notes in here like, well, those two should be the same ratio because the cosine of one angle is equal to the sine of the other angle. Same thing for cosine of 90 minus theta. That should be the same as the sine of the other angle theta. And remember, your tangents are just reciprocals of each other. So the original one was 40 over 9. So 90 minus theta should be 9 over 40. Okay, I use the same properties down here for these ones. But remember, in this, if you're only given two sides of a right triangle, use that Pythagorean theorem to find the third side. So once I did that, solved that, got 15 for the third side. And then from there, I just used my properties of SOHCAHTOA. You gotta remember this, SOHCAHTOA. So use that to find those other parts there. All right, guys. So that's really all there is to these kind. What I'd like to do is do a quick understanding check, something I want you to just try, if you want to, you can do it on a note card. You can turn it in. I can take a look at them. If not, you can just do them in your notes. I'll let the class decide on that one. But let's take a look at that understanding check. So here we go. Try this one out. Take about 5 minutes for that, and then come back and we'll check it together. All right, guys, so hopefully that went well for you. Here's the work that you should have done on this problem. What I've done is I've actually gone through and labeled in order the process that I went. First thing I did was read the directions. Second thing I did was, based off those directions, I drew a picture. Third thing I did was I used that information in the picture to find the missing side that I needed, that's 6. And then finally, step 4, I used SOHCAHTOA to find those 3 ratios. All right, so if you need to take a minute, look over that. Hopefully that all went well for you guys. So we're going to end this video here, and we'll pick up in the next video with inverse trig problems.